A software repository is a storage location from which software packages may be retrieved and installed on a computer. Overview. Many software publishers and other organizations maintain servers on the Internet for this purpose, either free of charge or for a subscription fee. Repositories may be solely for particular programs, such as CPAN for the Perl programming language, or for an entire operating system. Operators of such repositories typically provide a package management system, tools intended to search for, install and otherwise manipulate software packages from the repositories. For example, many Linux distributions use Advanced Packaging Tool, commonly found in Debian-based distributions, or Yum found in Red Hat-based distributions. There are also multiple independent package management systems, such as Pacman, used in Arch Linux, and Aquo, found in Sabe on Linux. As software repositories are designed to include useful packages, major repositories are designed to be malware-free. If a computer is configured to use a digitally signed repository from a reputable vendor, and is coupled with an appropriate permissions system, this significantly reduces the threat of malware to these systems. As a side effect, many systems that have these capabilities do not require anti-malware software such as antivirus software. Most major Linux distributions have many repositories around the world that mirror the main repository. Package management system versus package development process. A package management system is different from a package development process. A typical use of a package management system is to facilitate the integration of code from possibly different sources into a coherent standalone operating unit. Thus, a package management system might be used to produce a distribution of Linux, possibly a distribution tailored to a specific restricted application. A package development process, by contrast, is used to manage the co-development of code and documentation of a collection of functions or routines with a common theme, producing thereby a package of software functions that typically will not be complete and usable by themselves. A good package development process will help users conform to good documentation and coding practices, integrating some level of unit testing. The table below provides examples of package development processes. Selected repositories. The following table lists a few languages with repositories for contributed software. The auto checks column describes the routine checks done. Very few people have the ability to test their software under multiple operating systems with different versions of the core code and with other contributed packages they may use. For R, the comprehensive R archive network runs tests routinely. To see how this is valuable, suppose Sally contributes a package A. Sally only runs the current version of the software under one version of Microsoft Windows, and has only tested it in that environment, at more or less regular intervals. CRAN tests Sally's contribution under a dozen combinations of operating systems and versions of the core R language software. If one of them generates an error, she gets that error message. With luck, that error message may suffice to allow her to fix the error, even if she cannot replicate it with the hardware and software she has. Next, suppose John contributes to the repository a package B that uses a package A. Package B passes all the tests and is made available to users. Later, Sally submits an improved version of A, which unfortunately breaks B. The auto checks make it possible to provide information to John so he can fix the problem. This example exposes both a strength and a weakness in the R contributed package system. CRAN supports this kind of automated testing of contributed packages, but packages contributed to CRAN need not specify the versions of other contributed packages that they use. Procedures for requesting specific versions of packages exist, but contributors might not use those procedures. Beyond this, a repository such as CRAN running regular checks of contributed packages actually provides an extensive if ad hoc test suite for development versions. of the core language. If Sally gets an error message she does not understand or thinks is inappropriate, especially from the development version of the language, she can ask the core development team for the language for help. In this way, the repository can contribute to improving the quality of the core language software. Repository managers. Software to manage repositories includes Apache Archiver, repository management software for a build artifact repository. MyGet, continuous delivery service hosting 1000s of NuGet, Bower and NPM package repositories. JFrog's Artifactory, managing binaries throughout the development cycle. Sonatype's Nexus, used by over 20,000 organizations. Package Drone, a package manager repository for OSGI.